Hello and welcome to the next video of the course. This time I will talk about lambdas, lambda helper functions, and everything around. This will possibly be the longest video on this channel, so please stay with me because it's very important and it's a highly cool technique I use very often. But to use them, we will start with how to use tables inside Excel. Well, in Excel, you can create addressable or referenceable tables simply by selecting the cells and then click on Insert Table, or selecting the cells and then click Ctrl T. And now you can use this table in Excel, for example, in formulas. And this will make formulas more understandable and more intuitive to use. Well, this is the same formula here. So sum if S, instead of column G, you have fortune market cap. Instead of C, column C, it's fortune country. So you know, oh, this is the market cap, this is the country, and so on. And you can see this. And another advantage is if the table is updated, the new entry is automatically included. This is highly relevant when you don't work with whole columns or rows. So let's see how this will work in Excel. So we select all those cells here, and then we go on Insert, Table, and it's C0. Okay, this is your table. It has headers. Yeah, it has headers. And you click on OK here. This will be a little bit differently formatted, but you can also deselect this that you don't have this. And then you can work with it. For example, some how's my table called? Sorry, you can also name this table here. 500. I don't know, it's not an appropriate table name. Name this fortune because it's from the Fortune 500 list. And then you can type in some fortune and then some sales fortune. Yeah, here fortune, then edgy brackets, and then sales. Then close edgy brackets, and you have the sum of the sales here. So this could be one thing where you could use tables then. Another thing are the so-called names. In Excel, you can give cells or cell ranges own names simply by selecting the names and then go on the name field here, or use the name manager. And you can also use those names, those defined names within formulas and so on, as with the tables. So you can also name this here sales, or here profits, then go to formulas, go to name manager, go to new, we want to name this profits, and you have this done. So here sales, it will hand out a dynamic array, and if you sum this up, it will be the same result as with the table, you see. And you will later know why I do this in the Lambda course with the tables and the named ranges. So, and now we're coming to the lambdas. Here we have an exercise. You have generic words based on a list, and you need to remove or ignore them and create a list of the unique words, so the words who aren't generic and that occur more than once, and count how often they appear, and then build a table based on an descending order, and also do the headers here, for example. Here you have the text. You need to find those unique words, those non-generic words. And how many formulas do you think you need for this? 5, 10, 100? It's only one formula. Here is an example. It isn't that long. It could also be a little bit more shorter. I'm normally tend to do longer formulas, but never mind. And we know most of the formulas. Here you have an if error function, text split is here, a filter is here, unique is here. So you know most of them. And the rest you will learn, and you will also learn how to do this. So this formula will output this here based on this and the list of generic words on the more right side. And with this we will learn 5 functions today. One is the lambda function. The lambda function is only available since the end of 2020. And with the lambda function, Excel is a programming language in its own right, because with the lambda function, Excel became Turing complete. So also the Excel formula language is a programming language. And with the lambdas and the lambda helper functions, and especially in combination with dynamic array, Excel will reach another level or reaches another level, and you can do very complex formulas which were very hard before very easily. And when is lambda useful? To create your own functions and to use lambdas in formulas in combination with the so-called lambda helper functions. So here is a lambda function and the syntax of a lambda function. So you hand out different parameters to a lambda, and then you have a calculation based on this. And then if this lambda is not directly used in a formula, you need to define this the lambda function via the name manager. Therefore, we talked before about named ranges. So you type in the lambda function here, lambda x y x plus y, and it gives this a name. So in this case, my lambda, and then click on OK. And now you can use this lambda, and instead of typing here 9 plus 8, you only type in equals my lambda and reference to those cells. So here lambda needs parameters and a calculation at the end. So we have up on 100 parameters and so on, and you have one calculation as an output. But this was a very easy example, and most often those lambda examples are bananas. I've also only used lambda functions when I had a lecture by Craig Catmaker, who showed very complex and cool lambda tools and not those easy summing tools I showed you before. So here are a few more useful application ideas for lambdas. Rewrite existing formulas if you want to find them quicker or want to have them easier to use, for example, for the financial sector. So the financial Excel formulas are not so cool, I think, and therefore I rewrote some of them for myself. And then to use the lambdas in combination with lambda helper functions, as I've told you before, and also to write your own formulas. And you can also set up your own lambda library, and we will show this in an instance. And you can use them across several workbooks. It isn't that easily possible. You need to copy a worksheet from a workbook who contains a lambda to the workbook where you want to have this new lambda, or you could use the Excel Labs add-in in combination with GitHub. Yeah, but there isn't currently a thing to share them easily and to also to have them available in your Excel every time. But I was told that Excel is working on this, that the Excel product team is working on this. So possibly we will have a better solution for this. So, but I will show you then here a little bit about lambdas. So this is, for example, a lambda I've used here. It is the so-called two-stage terminal value. It's a very complicated formula. And I've wrote this lambda here, where you have, it's quite long. Yeah, not so long. And then to calculate the two-stage terminal value, I only need to type in two-stage TV because I've named it that way, and count out the values. Here, the cash flow, the WACC, the number of periods in the first stage, the growth rate in the first stage, and the growth rate for perpetuity, and it will hand out a value. So you can do, this is a formula I wrote myself. You have this very complicated thing used in financial models, and you can use them. I can now use this formula everywhere when I copy it in. And you can also do something like this. This is my Lambda library, currently over 180 formulas. And we will now discover what you can do with those formulas, for example. So, for example, reverse a text. So I type in reverse string, hand out a string, and it will reverse that string. You could also search from right. Search from right. This isn't natively possible in Excel, but you can do this with a lambda. If it will work. I had this problem before because I've copied here multiple times lambdas in. Yeah. Let me fix this in a second. Sorry, this was my fault. I should read properly. So define text is the text we will find, and within text is the text we want to search in. So then here, for example, to do descriptive analysis, here our array, and then only the basics, because this formula takes a while, because it does a lot of calculations. If Excel will hopefully not crash. Yeah, as I've told you, it will take a while. Because it will do multiple billion calculations. Because we have 2,000 rows, and their lambda isn't written to be that efficient. It could be have been written more efficient. So sorry, I will shorten this, only calculate so like 200 things. And here you have it, for example, the sum of the whole thing and the maximum value, the average value, the number of values, and so on for those values here. Then count something that appears most in area, but I want to have the value, most of value in area. Here, for example, how often something appears. The 10 appears 1,550 times, and the 8 only did that much, and it's, you see there are 15,000 values. So this formula is also quite advanced. And this, the lambda maze solver. So if you want to have the shortest route from here to here, you can use the maze solver and move path map. I need to enter the map where 1 is the way. Then I want to have the start address and the target address, and you can see 50,000 6 is the answer to go from here to here. So you see, you can write your own formulas, and this can be very cool. For example, if you work in a company and you have some things you use often, then you can do with lambdas your own formulas and share them with your colleagues, and you all will be faster than in your work. So this was the lambda part. Now a little bit of a pro tip: use the Excel labs add-in, because it not only includes the possibility to share lambdas in combination with GitHub, it has also an extended name manager, and which is not bound to the name manager character limit of 2000. I faced this limit once and needed to use the Excel labs add-in there before. It has also an AI feature and the so-called advanced formula environment, where you can view and debug your formulas much more better. So you see here, this formula would look that way then. So a little bit more structured, a little bit more like an IT environment. Here, the Lambda example from before, we've seen this in Excel then, two-stage terminal value, and you only insert the Lambda into your own library, if necessary, add an explanation, and the Lambda is ready to use, and you will never face this formula again. You can only use the Lambda then. And to call the Lambda as before, only type in the name of the Lambda and pass the parameters hard-coded or as a reference. You can also use optional arguments in Lambdas, in pre-programmed Lambdas. For example, with you can use edge brackets here, and then you need to use different things to tackle them. I will not go deep into here. For example, if functions, max, min, isomitted, to see if the value is there, because the lambda expect to have a value then, and if you leave that out, you need to do something about this. Let's call it that way. It's a nice course, so if you want to go deeper into that, I can make a video on this later on. So here, for example, another example here with the inster ref. So searching from right. For example, here the start number, and I use isomitted to find out if the start number isn't there. So, and then also a very important function, the so-called let function. With the let function, you can do two things. You can simplify your formulas, and you will face performance improvements. The let function always needs 3 plus x multiplied with 2 elements. So 1 plus x names, 1 plus x values, and one output value who can also be a calculation. So here you give the let function a name, then you have a variable or value. This could also be like a reference to another cell, and then you have a calculation. And you can also have multiple names and multiple name values there. And name values could also be calculations. So, for example, simple example here, if you want to filter out the blanks from an area, you would use here without let, you would use here 2 times the unique function, and then Excel will do both, calculate 2 times the unique values here. So Excel isn't intelligent in this case, and you also need to input it here twice, so it's a little bit unnecessary. And with let, you can type in let u for unique, then type in the function, and this function will only be calculated once, and then use the filter function here, and with the u as an argument there. It's shorter, it's clearer, it's the complexity is reduced, and the range here also needs to be adjusted once, and it's faster because of the improvement in calculation time. And here, for example, a comparison what you can do with or without let. Here, this is the same formula, but one time with let and with pre-programmed lambdas, quite small. Here without let, but with pre-programmed lambdas, And here, this is the formula if you don't have let and don't have pre-programmed lambdas. So you see, complicated. I can also show you this in Excel, how this will use, how this would look. Here, this is with let. It's the same formula, the same result here. With let, without let, and here without let and without pre-programmed lambdas. So see here, you can't debug this formula. No one on earth can do this then. And you see it's the same result. So very let formula there. And here also the let function, for example, I can use it here. Let's name this S for we want to sum it up, and then type in sum, let sum, and here we sum those values up. And also it isn't that's important here, but you can also use here S for this column and C for this column. Now we can do in sum if S. So we want to sum up S if C is 1. And this will also work. So a little bit more structured here. It could be very more complicated than as you saw with those examples here. And I can highly recommend to use let for complicated issues. It will help immensely. Also a pro tip, you can call up lambdas within let and only need to write them once and use them several times. You write your normal let function, then determine a name for this internal lambda, then set up the lambda normally. Here, for example, this is your name for your internal lambda, then you have this lambda a, and here you do something, it's only exemplary. And if you want to call this lambda then inside your let function, you use this, or you write the lambda name and then hand out the values here to the lambda. This could also be more than one value. But your input value should have the same structure then. So if you want to if you want to hand out an array, but your input value should be in only a single cell, then you would face a problem. But this is highly advanced here. And it's useful, for example, for this tic-tac-toe example. I've once solved this, and you need to scan line by row and column by column. Here for this and this. And with an internal lambda, you can do this quite easily, and then you only need to call them or use them with another function here to use them. Then there's the map function. The map function applies a formula internal lambda to each cell. For example, here we have an array and we have a lambda, and if this value here, if one cell is larger than 4, we do the cube, otherwise we will hand out the value not cubed. So we can do this here. For example, map this array lambda a. If a is larger than 10, then we want to have the third power, otherwise we want to have a. And you see here until 10 it's not cubed, and up until 10 it's cubed, not cubed, power of 3. And the map function applies this lambda to each cell. So this cell, this cell, this cell, this cell, this cell. The BYROW function, here, later on. For example, here, if you want to solve this here, here, this is an example where to use it, but you should be cautious because the map function can't handle arrays as an output. This is a problem, the so-called array of arrays problem. There are formulas to handle arrays of arrays. For example, the reduce function, or it's the only function that can handle this. Yeah, but you need to pay attention for this, and you should connect them before you print them out. And as I've told you, the map function only applies it to each cell, and the BYROW function applies it row by row. So here, if you want to have the maximum value, for example, for row by row, then you write in BYROW lambda A max from A. You can also sum row by row. And you can also do this column by column. So with BYCOL, you can have the sum or the max here. So here, for example, the sum by row, by type in by row, we will need the array, then type in lambda A, or you can also name this differently, and then sum and give the sum function the t here. This was not intelligent. Yeah, and you could also do this BYCOL lambda A sum of A. Here you have the C55, and you see here 15. So this will apply a lambda function either row by row, column by column, or if you use the map function cell by cell. Then with the new beta function, there are also a few predetermined functions for the BYCOL and BYROW function. So you don't need to type in this lambda stuff here. You will only need to type in hand the BYCOL or BYROW function to array, and then type in max or the other formulas that are available. But currently this is not available on the current channel, but it will. I hope to have it soon on the current channel. For example, also with group by and pivot by functions. Here you see how to use it, for example, here with a complex formula to extract the total numbers of this. Yeah, you see the lambda function is used, and we will use this for every cell here. But you see the lambda function, the internal lambda, could be also very more complicated, quite more complicated. And you can also, this will make Excel very, very cool if you use lambdas and dynamic arrays in combination. For example, but you should pay attention what you do, what the result is, and what the input is. So if you want to sum, if you have a dynamic array, what is the extent of my dynamic array, and so on and so on. What did I pass to the lambda, and what am I currently calculating with? And as I've told you before, there are a few advantages: better performance, it's clearer, new data is not so easily overlooked, and I highly recommend the let function to use it. With the let function, you can also use the so-called one formula approach, as I do with my challenges on this channel. Yeah, and you can then copy this formula more easily to other tasks instead of copying multiple formulas. With this, we are at the end of this Lambda video. I hope you've learned something. If you have any questions, I think I know it's quite hard to understand and to get it, and it was a lot of things to learn here. So please feel free to reach out in the comments, and otherwise I'll have an exercise here available for you. Feel free to do it. I will link it in the video description. I hope to see you in the next video. Bye.